Okay, so what I want to do here is go over the lab activity, make sure you're on the right track with what you're doing there, and that's in terms of both the form and the simulation itself. So first up, go ahead and pull up the lab activity, the handout, and you're going to want to read over the purpose or the background. So take a second, pause the video, do that. Now what we're going to be doing in this lab is calculating the net force on various numbers of forces and then figuring out what the equilibrium force would have to be to bring everything into balance, because that's what an equilibrium force does. We know that when there are multiple forces acting on an object, that there's going to be a net force acting on them. So some resultant. It's going to tell you which way the thing is going to go. It's going to tell you what acceleration it's going to be traveling at. This equilibrium force brings it all back into balance. It brings it all into what's called an equilibrium. Equilibrium is when the net force on an object is 0 newtons. Now 0 newtons means the object is at a constant velocity. So it's moving at the same rate of speed, same direction of travel, no acceleration. In this particular one, we're looking at it in terms of it's going to be stationary, which is still a constant velocity, it's just 0. But we're looking at what force would it take to bring an object into a stationary position. So I'm going to go ahead and work through this first one, this example of how to find the equilibrium force for these three that are here. So with this, we need to do what we normally do to solve for net force, and that is to break all of these into components. So this 52 degrees, that should be located up here. And we're going to label these F1, F2, and F3. Notice with F1, you're going to want to use the cosine function to get your x component, the sine function to get your y. For F2, 60 is measured off this y-axis. You got to flip that. You're going to be using sine to figure out x and cosine to figure out y, and same thing for F3. So go ahead and work through those, see if you get the same answers that I do. Okay, so there we have all of our components for the three forces, the x's and the y's. Next bit is we're going to want to figure out the components of the net force, so Fx net and Fy net. So remember, you need to consider which direction things are traveling in order to add those up correctly. And I'm going to do those down here in the bottom left. Check and make sure that yours match up. And there we have our component values. We have negative 37.3 newtons and negative 107 newtons. So what that tells us is that our net force triangle is going to look like this. So our total net force is going to be directed down into the left, so that third quadrant, at some angle theta. Now we need to go ahead and solve for these. Remember, to solve for the total net force, you have the two sides of this net force triangle. You can use the Pythagorean theorem to get the total. To get the angle, since you have the x and y components, go ahead, or adjacent and opposite components, go ahead and use the inverse tan function. Work through that, see if you get the same answers. So there we are. We have a total net force of 113.3 newtons and an angle of 70.8 degrees. Now this angle is going to be from the negative x-axis down. So if this is our net force, we need to bring this all into balance. And we bring it into balance by putting in an additional force, this time being a fourth force, that is exactly the opposite in magnitude and direction as our net. So if we have 113.3 directed down into the left at 70.8 below the negative x, our equilibrium would have to be the same value but off and to the right above the positive x-axis. So that's how we go about solving for the equilibrium force. You're going to be doing that for the setups 3 and setups 4. So to look at those, you have your link here for the lab, and that's also going to be on the class site as well. But for your setups, you have an image of what the setup should look like. You have a bit of direction telling you what you need to do. And this table here is where you're going to be plugging in the values that you were solving for. So the first row here, the magnitude in newtons, that should be whatever the value is. So 17.7, 14.1, and 13.2 in this example. You want to put in the angles there. The angles, you can either put in the angle that's shown on the charts, or you can put in whatever angle you are using for your calculations. So if you were using the angle that the thing is off of the x-axis, put that value in there. If you're using that as the y-axis, put that value in there. But then also put in whatever that reference axis is here. Now that is to keep track of whether or not you're using sine or cosine for the different components. Now you're going to plug in your x components for the force values that you solve for, also the y components. So these three columns are where you're going to work at first. Once you get those answers, you can also plug in your signs here. So if it's in the positive x direction, plug in a positive value for the x component. If it's in negative x, plug in a negative value. Same thing for the y's. What that allows you to do is then work from the bottom up to find your net force. So your x component, or you're starting off with your y component, just add straight across. Get your y component for your net force. Add straight across this to get your x component. If it comes out as a positive value, that means your y is a positive y component. If it comes out negative, it's a negative. So after you get these, then you can tell what axis you're referencing here, do the angle, inverse tangent, and then Pythagorean theorem to get the magnitude. In this section here, screenshot of the forces. So once you have your setup done, go ahead, take a screenshot of that, plug that in here. Just use the snipping tool to put that in there. And then once you figure out what your net force is, what I want you to do is go ahead and draw that net force onto this. Okay, so draw that net force on there, screenshot that, plug it in here. You're going to do the same exact thing for setup 2. Only difference here is you have an additional force. For setup 3 and 4, it's a little different. You're going to go ahead and find your components to your A, B, and C forces, find your net force, and then your equilibrium force. So remember that your equilibrium force is the same magnitude, it's just in the opposite direction at the same angle. So if you are referencing the positive x-axis here, you might be referencing the negative one on your equilibrium. If the angle is 30 degrees above the positive x, here would be 30 degrees below the negative x. Magnitude should be the same though. The components will be oppositely signed. So if this was positive, that's now negative. Now the screenshot here on the left, I want you to do of your net force. So once you get your three forces on there, draw your net force on there, and screenshot that, put that on. Next thing you're going to want to do is go ahead and remove that net force arrow that you just drew on there, and then replace with your equilibrium. So put the arrow on there that represents your equilibrium force. Then take a screenshot of that, place it there. If you want to check your answer, your equilibrium force is correct. Once you have the equilibrium force drawn on there, if you then tick the sum option in the simulator, then it's going to give you a sum of 0 if you're correct. You can do the same thing before, except you have 4 forces. and then work your way down into the questions below. Okay? The last bit is a challenge question. This is going to be trying to figure out the net force for a three-dimensional problem. So it works just like a two-dimensional problem, except for you have the additional third. So what that means is now your F1, 2, and 3 have X, Y, and Z components. So a left, a right, a forward, a back, in and up and down. You're going to work that just like the other thing. You're going to break it into X and Y components and Z components, and then work your way up the chart to find your net force. So I want you to give this one a try and show me the work you did to try and figure that one out. Now here is the simulator. The simulator is going to be the lab tab here. You're going to want to drag your origin to the center, and you can choose the arrows from here. Go ahead and move your arrow in. You can drag it over to where you need it. It'd be nice, but you cannot actually click here to edit those. You have to move this around to get it close to what you need. You can drag in as many forces as you would like. You can have it show the angle here and the values, that way you know what it actually is and which way it's going. And for the sections where you need to find like the sum of these forces, what is that net value? If you click this option, this is your net force. So the sum of those three together results in that. Okay? Which is kind of odd considering, let's check. There we go. You don't want the red sum, you want the blue sum. This. Okay, that like makes a little bit more sense. So that is your net force. Okay, so that's the sim. When you're done with things, you just kind of have to move these off to the side and you can get rid of them. Just erase the entire thing or reset the whole thing. It's up to you. Now again, make sure you are working in the lab tab of this one. Now if you have any questions about what's going on, make sure you stop by during my office hours. They are 8:30 to 10 and 12 to 1:30 every day of the week. Well, every weekday of the week. Have a good one.